These 21 questions from various versions of the SAT cover the same content we've talked about throughout Chapter 1. Number 8 goes back to this idea that the exterior angles of a regular polygon are equal to 360 degrees divided by n. Now they called A the exterior angles and they moved this n over, but it's the same formula. So what we can do is we can plug in different numbers here for n and figure out which one will give us a value that is greater than 50. So if you carry out that operation for all 4 possible answer choices, what's the greatest number that's still bigger than 50? And that's this one right here, 7. Number 11 has to do with vertical angles and various other angle equivalencies. For example, in addition to knowing that x plus y is equivalent to u plus w, we know that vertical angles are equal, like y and u. So what that means is that x and w then are going to be equal to each other, since these two angles have to add up to the larger angle, using that angle addition postulate. And we can further say that x and t here are vertical angles, and w and z are vertical angles. So if you track the colors there, is x equal to z? Yes, they're both green. Is y equal to w? We don't know that one. Is z equal to t? Yes, they're both green. So 1 and 3 only is the best answer. For number 20, we can use a linear pair to figure out this angle here. If we take 180 minus 106, this is going to give us 74 degrees. Then to find out this missing angle, we take 180 and we subtract 74 and we subtract 23, these other two known angles. And this gives us 103. And then finally, here at the end, to figure out this one is another linear pair. So this is 180 minus 103, and that gives us an answer of 97. So x equals 97 degrees. So big word problem here. To summarize it, we're going to take height plus the perimeter of the base of the box, and it cannot exceed 130. So h plus p is less than or equal to 130. And they go on to tell us that the height is 60, so we can plug that in here. So then if we subtract 60 from both sides, the perimeter has to be less than or equal to 70. So let's make this our box, and its length is 2.5 times the width. And we'll call the width x. So let's say this is the width, and this is the length, so it becomes 2.5x. The total perimeter here then, if you add up all the x's, is going to be 7x. So we'll say 7x is less than or equal to 70. If we divide both sides by 7, we get x is less than or equal to 10, which is A. The width of a rectangular dance floor is w feet. The length is 6 feet longer, so we'll call that w plus 6. If we wanted to find the perimeter, we just add up all the w's, that's 4w, and then we add up the 6's, that's 12, B. So this entire angle adds up to 180 degrees, and we know that there's 90 degrees over here, which means that this whole side, those three angles put together, equal 90. So we can say x plus 2x plus 2x is equal to 90. If 5x is 90, then x is equal to 18. They want to know what is 3x. 18 times 3, 54. For number 7, first we can figure out x by knowing that all the interior angles of a triangle add up to 180. So if I subtract 105 and I subtract 35, x here is going to be 40 degrees. Since x and y here form a linear pair, y is going to be 140 degrees, since it's 180 minus 40. If I plug these in, 140 for y and 40 for x, and subtract the two, I get c, 100. If I draw a line here, number 11, to divide this into a square and a triangle, I know that this length is 4 and this length is 4, so this one must be 3. On the left side, I can take 4 times 4 is 16 for this area. Here I take 4 times 3 and I divide it by 2, so the area is 6. If I add those two areas together, I get 22. There's a variety of ways I could solve 27. I see a rectangle problem with percents, so I'm going to create a type of rectangle, a square, that has a length and width of both 10, since they didn't give me values. I'm going to pick some easy to use ones. And the area then would be 100. So let's apply some of these transformations they're talking about. the length is going to increase by 10%, so that 10 is going to become 11. You could do that by taking 10 times 1.1. The overall area is going to decrease by 12%, so the new area is going to be 88, since we are going down 12%. And what does that tell us about the width? Well, we could just take 88 and divide it by 11. And what do we get? We get 8. So what percent did we decrease by to go from 10 to 8? You can take 8 divided by 10. That tells you you're at 0.8 of your original. We have decreased by 20%. They tell us that PQ and RS are equal. I can set them equal like this, 2x, and I add 7 to both sides. This is 6. X is going to be equal to 3. And they want to know the length of PS, so that's this entire thing. So I'm going to plug in 3 in this spot, right down here, and over there. So if I carry out these operations, I have 2 plus 3 is 5, and here I have 9 minus 7 is 2. So my total is going to be 7. We are designing a rectangular garden. The length is going to be 5 feet longer than the width, so we'll call the width x, and the length we'll call x plus 5. So if I wanted to find the area there, I multiply the two, x times x plus 5, and this gives me x squared plus 5x, and this is going to be equal to 104 square feet. You could also probably accomplish this by guessing and checking some different numbers. If we just started with 5 and 10, that's not big enough. So what about 10 and 15? Well, that's too big. So how about 8 and 13? Well, those turn out to be the answers. And since the length is bigger, your answer is going to be 13. We could solve this quadratically by setting equal to 0 and factoring. However, at that point, we're already finding factors that multiply up to 104 and add up to 5 anyway, so why not just guess and check? This is a polygon with 1, 2, 3, 4 sides. If we use our formula, we figure out the interior sum is 360 degrees. So 45 plus 3x, because x shows up 3 times, is equal to 360 degrees, which means 3x is equal to 315. So x is equal to 105, D. Here we know that x is equal to 100 degrees, which means this angle is 60. There's another vertical angle. This one is also 60 degrees. So using the sum of the interior angles of a triangle, we can figure out that y is equal to 80 degrees. That's the answer, C. Next up, the interior sum is 180. We know that this is 34, so what is 180 minus 34? Well, that's 146 degrees. There's a poster with an area of 432 square inches. The length is x, so L is equal to x. And that's bigger than the width, so the width is actually going to be x minus 6. We usually set that up backwards, but here, this is the direction we're going in. So if I multiply these two, x times x minus 6, I get x squared minus 6x. And that is equal to this area 432. We don't have to go any further than there. We have our answer B. So this is a right triangle here at the top. And I know my hypotenuse is 10, and one of my sides is 8. So 10 squared is equal to 8 squared plus b squared, whatever that is. And it turns out this is a pretty common Pythagorean triple. We have 64, we have 100, and this must be 36, so that's going to be 6 squared. So that side length is 6, and the same thing is true of this one on the left. So the top of that rectangle, or the width of it, I suppose, is 12. They tell us that the area down here is 180. So I can take 180, divide that by 12, and whatever I get is x. And the answer is 15. Here we're looking at 12 glasses fitting inside of this container. We see a row of 1, 2, 3, 4 multiplied by 3. There's 12 glasses that fit in there. They're telling me that the length and width of the container base are doubled. So another 12 inches this way, another 9 inches this way. If you look, I now have that original box over here, and over there. So those 12 glasses are multiplied by 4, and I now can store 48. But they want to know how many more. So there's an additional 12 here, an additional 12 here, an additional 12 there. The answer is 36. Similar question, but now the area is 25% greater than the base in the initial sketch. So 12 times 9, this gives me 108. If I'm going to take 25% greater of that, I multiply it times 1.25. This will give me 135, and that's my new area. So the initial equation for perimeter is twice the length plus twice the width is equal to perimeter. When they say which of the following represents L in terms of the other variables, what they're saying is solve for L. So the first thing I might do is move the 2w over to the right. Then I can divide everything by 2. On the left, the 2's cancel out. I'm looking for p minus 2w over 2, c. So the last problem, a bit of a doozy. I have a garden that has a length that is 9 feet less than 3 times its width. So if I call my width x, then my length is going to be 3x minus 9. So I can take length times width and equal that to area. So here I have x times 3x minus 9 is equal to 5,670. I could move that 5,670 over to turn this into a quadratic. And if I factor out a 3 out of everything, if I wanted to figure out what two numbers multiply to make this and add to make that, well, they're going to have to be very similar to the square root, since this is a large product and there's only a difference of 3. So I took the square root of 1,890 and I got around 43. So I figured I'll pick some numbers that are near 43. I tried 45 and 42. And it turned out, if you multiply those together, you get 1,890. And since my b value here is negative 3, I chose negative 45 and a positive 42. Since our width can't really be negative, I'm going to pick this one as my x value. That tells me that x is equal to 45. So over here, x, which is my width, is 45. If I triple that and subtract 9, I get a length of 126. So I add these two together and I double them, and I get 342. 90 plus 252. Just kidding, there's one more. We have a square and an equilateral triangle, both formed by metal rods of the same length. So we'll consider this square has 4 side lengths of x, and the side of the triangle, they're 2 inches longer, so we'll call that x plus 2 on all 3 sides. But the entire perimeter is equal to both, for both shapes. So 4x is equal to 3x plus 6 if I add up these 3 lengths. This tells me when I subtract 3x that x is equal to 6. And they want to know how long is each rod, so I'm going to plug that back in. 6 times 4, and the answer is 24. Or I could have plugged it in here. 3 times 6 plus 6. Both give you 24.